We'll now look at the calculus of matrices. We can take the derivative of a matrix by taking the derivatives of all of its entries, and we can find the integral of a matrix by taking the integral of all of its entries. Here I have a matrix t squared cosine t e to the t in 1, and I want to find a prime of t. In order to do that, we take the derivatives of the entries. The derivative of t squared is 2t, and the integral of 1 is 0. My next entry, the derivative of cosine t is negative sine t. Moving down to my second row, the derivative of e to the t is e to the t. And the derivative of 1 is 0. So I now have the derivative matrix. Here we have the same matrix A, but this time we want to find the integral from 0 to 1 of A. In order to do that, we're going to need to find the integral from 0 to 1 of each of these entries. So before we put this back into matrix form, let's think about what each of these integrals are. The first one is the integral from 0 to 1 of t squared plus 1. The integral of that would be 1/3 t cubed plus t from 0 to 1. And when we stick in our bounds, we get 4/3. So that would be the first row, first column of our solution. Now let's go to cosine t. This means we're going to consider the integral from 0 to 1 of cosine t. This then gives us sine of t between 0 and 1. And since sine of 0 is 0, we just get sine of 1. We move on to our next entry. Integral from 0 to 1 of e to the t. We know that the integral of e to the t is just e to the t. And if we stick in our bounds, we get e minus 1. That would be the result in the second row, first column of our solution. Finally, I need to consider the integral from 0 to 1 of 1 dt. The integral of 1 is just t. And if I stick in my bounds, I get a solution of just 1. And with that, I have my solution matrix. Here I have a vector x of t, which is cosine omega t sine omega t. I have a matrix A, which is 0 minus omega, omega 0. Now I want to actually show that this vector x is a solution of this matrix differential equation, x prime equal to ax, where I've just given you A. So let's stick it in and see what happens. The left-hand side of this equation says x prime, so let's find x prime. We know that the derivative of cosine of t is negative sine of t, and then we need to take the derivative of the inside. This gives us that the integral is negative omega sine omega t. Similarly, we can take the derivative of sine omega t, and we get omega cosine omega t. So that was the left-hand side of the equation. We now need to look at the right-hand side of the equation, ax. So we have 0, negative omega, omega 0, times cosine omega t, sine omega t. When I multiply my first row by this column, I have 0 minus omega sine omega t. And then the second row gives me omega cosine omega t plus 0. And now this is the right-hand side of the equation. And we can see these two things are equal. So this is a solution to this matrix differential equation.